Okay, we're looking at New Zealand and we're asking the question, now why is Taupo, which was a series of volcanic eruptions with Ruapehu and the other ones, the other mountains, the other volcanoes in the North Island, why are they different from old volcanoes in the South Island? Yeah, like Christchurch and like Dunedin, quite different. So you've got weathering from a height down your rivers and particle sorting, and on your coastline you get sand. Now if it's a whitish sort of sand, it's silicate rich, yeah, and if it's a black sand, it's not silicate rich. So you get black sands and you get white sands, okay? So when we're looking at the North Island of New Zealand, this is my volcano. This is the Taupo volcanic zone, which was a mega volcanic blast once. It was huge. And then what we got blowing out of that and littered all over the plateau up there was this stuff. We got, and this is actually a piece of pumice. People picked it up and went, whoa, that's quite good. It's not the only thing that comes out of the volcano, because it dumps a whole lot of other stuff that becomes tuff, volcanic tuff. And you have it like sprayed everywhere. It takes dirt with it and rocks and all sorts of things. But we got pumice, and this Taupo eruption gave us pumice. And that's pyroclastic. It's light, it's full of gas, and it's made of this soft stuff. Now we considered that when the subduction zone on the east coast cracks and bends and then drops, it picks up all of the silicon-rich sand, and in it the sand are shells. And when you've got a rich shell population of shellfish, that gets driven underneath the lithospheric edge of the Indo-Australian plate at New Zealand, East Coast, North Island. And then it drives under and it sort of melts and gets hot. And because it's wet and silicon rich, it creates bubbles when it comes out, and it's in the rocks. And that's called a pyroclastic volcano. Now you've got other volcanoes that are not pyroclastic, because when the subduction occurs, it doesn't pick up all the shell life, right? And it's not silicon-rich sand. So if we go to the other subduction zone on the west coast of the South Island, we've got a completely different situation, because we don't have all of these shells there. And we don't have pyroclastics. We don't have this pumice come out. Because what we have is we have a set of mountains that are greywackies, and we have fjords, which are deep, and they don't have the white sand on the subduction zone. They've got fjords next to it, and when you go under the fjords and you dip so sharply, you don't pick up all this stuff, and so we don't get the pyroclastics, okay? So it's quite a different system on the west coast. And so Christchurch and Dunedin hasn't experienced a violent earthquake, and it hasn't reactivated. So when you get into stratovolcanoes like in Italy, and you get into cinder cones like in Washington, and you get into all these other types of volcanoes, then you get a whole course in volcanoes, because you've got all sorts of different earth processes going on around to create the volcano that you've got there. So when you get into volcanoes, there's a lot to learn. It's not just simply you have a volcano and then the course is over, 1 hour's lecture and it's done. It's more like a lifetime of how did we get this volcano and when did it blow and why did it blow and what did you get out of it and then what happened and how did that affect the valleys around and change life forms, and how was that with the Ice Age and how was that with your hydrology, and then you have to learn hydrology, and so it becomes this enormous wealth of earth processes embedded in a whole lot of other geology and geography and global biodynamics and asthenosphere and lithosphere dynamics when it comes to plate tectonics and rupturing and faulting and pugs and ejective gases and places like Ikaria next to Turkey near Naxos, all of that stuff coming out. Gabriel went there. You can go to Ikaria in the Aegean Sea and have a look at the situation there because that's still venting. Probably hydrogen sulfides out of the magma chambers there. So when it comes to earth processes around the Mediterranean and those in the Himalaya and those in New Zealand and then those in the Rockies and Washington and South America, then you've got, oh my goodness, you've got a whole planet full of interest when it comes to this sort of thing. Okay, so it's a big field, it's very interesting.